Hey everybody, it's Mrs. Dinkelman, and I'm trying without the headphones this time. I've been listening to my other videos. I can hear myself breathing. I don't like that. Anyhow, this is notes for lesson 3.3, which is called implicit differentiation. The opposite of implicit derivatives is really explicit derivatives. So explicit really means we were able to solve explicitly for y, and a lot of times it's just written that way, like a y equals something. For some problems, we can't really do that. So for instance, this x squared plus y squared equals 1, that's a circle. We can't really solve explicitly for y. I don't know if you've ever tried this on your calculator, so we know that that's a circle. On the calculator, we have to write this in two ways. We have to have the positive square root and the negative square root to get the whole circle. So that means we're not able to solve explicitly for y. So it just takes a little bit more for finding the derivative here. The procedure, I'm going to ignore that because I do this a little bit differently than most people. So the unfortunate thing about that is it'll be different from the way Mr. Spain teaches it. And then also if you look at solutions from Gary, it's going to look slightly different. I bet you'll be able to kind of see the pieces and make sure you have the right things, though. It's not that different. Okay, we're going to skip those warm-up examples, although they are really helpful to remind you in how to find the derivatives there. But we're going to skip down to the examples here. So the way that you can tell when you're doing a problem that you have to do this strategy is the equation has a mixture of x's and y's together, and it doesn't just say y equals. Okay, so that's how you know that this strategy is what you need to employ. So the derivative of x squared, that's the same. We're going to put a 2x, but because I took the derivative of an x, we're going to put a dx. That little thing right there is called a differential, and it just indicates that it's a derivative with like an x as a variable. And then the derivative of this next one is going to be 6y squared. Because I took the derivative of something with a y, I'm going to put a dy. Derivative of 3x is a 3. It had an x in it, so I'm going to put a dx. And then nicely enough, the derivative of 6 is 0, so I don't really have to put anything over there. Now my goal, it says, is to find y prime, but I'm going to write that as dy dx because that's kind of the symbolage I have here. So I'm going to have everything with a dy over on the left-hand side. I'm going to leave it there and move everything with a dx over to the left-hand side. Okay, there's a couple ways to go from here. But what I really want you to do, again, because we want dy dx, is we're basically going to divide everything in here by dx. So technically what I'm doing is dividing both sides here by dx. But what I can really do, because a lot of this is just multiplication, is I can say, I'm just going to divide the dy by dx. That way you can see I have the dy dx that I'm looking for. Okay. Over on the right-hand side, if I'm going to divide by dx, well, the nice thing is since both of these have a dx, the dx's are all going to cancel. So I just have a negative 2x minus 3 there. So now, if I want to get dy dx by itself, I'm just going to have to divide. So negative 2x minus 3 over negative 6y squared. Okay, we could simplify that a little bit by taking away all the negatives, but it's perfectly fine the way it is. Okay, so same thing on number 2. It says the slope of the tangent line, which is really the derivative. So we're going to do this because we have a mixture of x's and y's again. So 2x dx, 8y, that's a dy, equals 0. I'm going to leave the dy over here on the left-hand side and move the dx over to the right-hand side. And then remember my next step is to divide by dx. So dy dx is negative 2x over 8y. Now we can simplify that if we want to, or we don't have to. I'm going to go ahead and plug in that 3, 2 right now. So that's going to be negative 6 over 16, or negative 3/8 for the slope of the tangent line. Okay, so basically the same exact question, just a different problem. On number 3 here, we just need to find dy dx. They're just asking it in a different way. We need to be really careful about the product rule here because the things that have a product have a subtract sign there. So we really want to make sure that we distribute that subtract sign. Okay, so this is going to be 3x squared, that's a dx, minus. Now I like to just put parentheses here where I'm going to do the product rule to make sure that I find that or distribute that subtract. I'm going to think of 2x as being together and then y as being its own self. So first times the derivative of the second, that 1 was the derivative of y. So I'm going to put a dy there. In fact, you don't really need the 1, plus second times the derivative of the first, that's a 2, and that was an x that I took the derivative of. Derivative of y cubed is 3y squared, that's a dy. And then the derivative of the 5x is 5, that's a dx. Okay, so again, we want to gather all the dy's on this left-hand side and move all the dx's over to the other side. So let's see, there's a dx right here, but it's negative. A dy, excuse me. And then there's a dy here, 3y squared dy. And let's move the dx's over to the other side. So there's already a 5dx over there. This 3x squared needs to come over. He's negative though. And then there's a dx right in here. That's a 2y, but it's negative on this side, so it's going to be a plus right here. Okay, this time I think it's going to be easier since I have a lot of mess going on. Factor out the dy just so I can see what's going on. Those other ones that we didn't have a lot of mess over there on the left-hand side, so it didn't really matter. I'm going to go ahead and factor the dx out here in case that makes more sense too. Because again, now my next step is to divide by that dx. So that I have dy dx on the left-hand side. I'm going to kind of use up this space. I guess I'll have to erase for number 4. So that means I have dy dx here. I'm going to have to divide this giant term over in a second. So I'll do that kind of in one step as I'm writing. Okay, so the numerator is this 5 minus 3x squared plus 2y. And then I'm going to have to divide both sides by that negative 2x plus 3y squared to find my answer. And then they also wanted me to plug in the point 1, 2. So let's see what that's going to be. 5 minus 3 plus 4. And then let's see, that's going to be negative 2 plus, that's going to be 12. So 6 over 10 or 3/5. Okay, so let's go ahead and look at example 4. I'm going to erase all that mess. So example 4 is finding the second derivative. So we have to just work a little harder even now for the second derivative. So let's start with the first derivative. So luckily that's not too terrible. So 2x dx plus 2y dy equals 0. So we'll move the dx over and we'll divide by dx. So I'm just going to, again, technically in my brain, I'm also dividing by the 2y because I'm just skipping some steps. You can let me know if you have questions about that. I am going to simplify that one to negative x over y because if I have to use it again, I kind of want it to be a little simpler. So let's go ahead and now try to find the second derivative. So I'm going to not put anything over on this side right now. We can have a conversation about what belongs there here in just a second. We're going to have to do quotient rule here. I'm going to think of the negative as being up here with the x. So I'm going to go low, b high. That was a derivative of negative x minus high, d low. So that's a derivative is 1 and that's a dy all over low, low. Okay, so remember with this one, just like in first derivative, I also have to divide by dx, but I'm going to be a little bit sneaky about it because I don't want to work too hard about simplifying here. So I'm going to sneak the dx in where I know I can underneath the dx and the dy, just like has been happening all this time. So on that left-hand side now, we have y double prime, or another way that you see them write it is d squared y over dx squared. And no, that's not a mistake. The d is squared on the top because it's saying the second derivative of y, and the dx squared, technically that's in parentheses, both times with respect to x. Basically, it's saying we've divided by dx twice, if you want to think of it that way. Okay, so now this just becomes negative y. This is plus x times dy dx all over y squared. Now there's one last step. We actually have a formula for dy dx. That's what dy dx equals. So we want to go ahead and insert that into our problem. So let's see, that's negative y and then x times negative x over y. That is a negative, I better make sure it's in there. All divided by y squared. So now we're done because we don't have any of that dy or dx symbolage over there on the right-hand side. Okay, I'm going to stop for there. I want you to go ahead and get to the assignment and try those little dy's and little dx's. Remember, it'll look a little bit different versus Gary's method, but see if you can peek in there and see that it is technically similar.